We are in section 3.4 on page 5. At the top, we have derivative of a general exponential function. This is definitely something that you need to know, you should have memorized. And the first one says the derivative of b to the x is equal to b to the x stays exactly the same times ln of b times ln of the base for any b that's a number greater than 0. And then if you had the same thing but with the chain rule, b to a function g of x stays exactly the same times the derivative of that inside function g prime of x times ln of b, again for b being positive. So the first problem that we have here is y equals 3 sine of x. So going in and taking a derivative, dy dx is equal to, first thing, it stays exactly the same, times, this one has an inside function, which is our exponent. Derivative of sine is going to be cosine of x, times ln of our base. Not much you can clean up. You can reorder your terms if you want, but besides that, not much else you can do. For part B, we have f prime of x equals, and we're going to have e to the cosecant of x squared times taking the derivative of cosecant of x squared. You'll notice you have an outside function and an inside function. So the derivative of cosecant is negative cosecant theta cotangent theta. So we're going to have negative cosecant x squared times cotangent of x squared, keeping that inside function the same, times the derivative of that inside function, which is going to be times 2x. You can clean this up, pull the negative out in front, rewrite it a little bit nicer. Again, check your answer on Canvas. I'm going to go ahead and have you guys look at C on your own, but let's jump and look at D. D says y equals x squared times e to the negative 1 over x, and I'm going to go ahead and rewrite this as x squared e to the negative x to the negative 1. So finding our derivative, dy dx equals, and we are multiplying two things that involve an x, so we have to use our product rule. So we're going to have x squared times the derivative of that second term stays exactly the same. We have e to the negative x, the negative first, times the derivative of that exponent, which is negative x to negative first, and the derivative of this is going to become negative times the negative would be positive x. Subtracting 1 from the exponent would be to the negative second, plus the second term, which is e to the negative x to the negative first, times the derivative of our first term, which is going to be times 2x. This is definitely something you have a GCF. You guys can factor that out. You can clean this up quite a bit. So see if you guys can simplify this and rewrite your answer. Check on Canvas to see how that was written.